Have you ever wondered what role exosomes play in insulin resistance? Well, today we're going to uncover this fascinating topic. Welcome to the Victory Education Lounge. I'm your host, Maurice, and today we're diving into a cutting-edge topic, the role of exosomes in insulin resistance. This is part 66 of our ongoing series on health and wellness. Before we begin, please take a moment to like this video, subscribe to our channel, and leave a comment sharing your thoughts or experiences. Your engagement helps us reach more people with this valuable information. Let's kick things off by defining our two key terms, exosomes and insulin resistance. First up, exosomes. Picture these as tiny cellular couriers carrying an assortment of proteins, lipids, and genetic material from one cell to another. They're essentially the postmen and women of our cellular world, ensuring that crucial biological messages are delivered right where they need to go. Now, on to insulin resistance. This happens when the cells in your body start to shrug off the effects of insulin. Imagine you're at a concert and the sound technician keeps cranking up the volume, but no matter how loud it gets, you just can't seem to hear the music. That's what insulin resistance is like. Your body keeps producing more insulin, but your cells just aren't picking up the tune. So why is it important to understand the connection between these two concepts? Well, as it turns out, our little cellular couriers, the exosomes, might be playing a significant role in the development and progression of insulin resistance. They're not just delivering mail, they're influencing the very processes that could lead to chronic conditions like diabetes. This is an area of medical research that's gaining momentum, and for good reason. Understanding how exosomes contribute to insulin resistance could open up new avenues for prevention, treatment, and possibly even a cure for conditions related to insulin resistance. So, as we delve deeper into this topic, we'll be exploring the complex interplay between exosomes and insulin resistance, looking at examples of their involvement, and discussing potential strategies to manage and prevent insulin resistance. Let's now delve into the specifics of how exosomes are involved in insulin resistance. Now, let's explore 10 ways in which exosomes are implicated in insulin resistance. Firstly, exosomes play a role in adipose tissue communication. These vesicles from fat tissue can carry molecules that encourage insulin resistance in other tissues. This cellular chatter is a crucial factor in how our bodies respond to insulin. Secondly, there's muscle-liver crosstalk. Exosomes journeying from muscle cells have been found to influence insulin sensitivity in the liver. This interaction can shape how the liver processes glucose, thus affecting insulin resistance. The third point to consider is the impact on pancreatic beta cell function. Exosomes can alter the function of these insulin-producing cells. This may affect insulin secretion, further contributing to insulin resistance. Fourthly, exosomes are involved in inflammation mediation. They can carry pro-inflammatory factors that contribute to insulin resistance. By exacerbating inflammation, exosomes can indirectly influence insulin sensitivity. Next, we have microRNA transfer. Exosomes can deliver these tiny RNA molecules that regulate genes involved in insulin signaling. This genetic regulation is a significant aspect of how our cells respond to insulin. Our sixth example is lipid metabolism. Exosomes can affect how our bodies handle lipids, which is closely tied to insulin sensitivity. Changes in lipid metabolism can directly impact the development of insulin resistance. Seventh, exosomes are linked with endothelial dysfunction, a feature of insulin resistance. By influencing the health of our blood vessels' inner lining, exosomes can affect how our bodies process insulin. The eighth example is macrophage polarization. Exosomes can sway the polarization of these immune cells, affecting inflammation and insulin sensitivity. This immune modulation can indirectly influence insulin resistance. Ninth, we have skeletal muscle insulin sensitivity. Exosomes from various tissues can impact how sensitive our skeletal muscles are to insulin. As these muscles are major consumers of glucose, their responsiveness to insulin is crucial. Finally, exosomes may influence hypothalamic regulation. The hypothalamus, a part of our brain, plays a significant role in controlling metabolism and insulin sensitivity. Exosomes may affect this control, further tying them to insulin resistance. Understanding these connections is vital, but what can we do about it? Let's discuss potential solutions next. Now that we have a grasp on the role of exosomes in insulin resistance, let's explore potential solutions and strategies to manage this condition. Exercise is a key player in the game. Regular physical activity can positively modulate exosome content, promoting overall health and well-being. However, it does require consistent effort and a time commitment. So, dust off those sneakers and get moving. Next up, we have dietary interventions. Certain foods may influence exosome production and content. This is a natural approach to health, but it may require significant dietary changes. So it might be time to rethink that daily donut and replace it with a delicious apple. Intermittent fasting is another strategy that's gained popularity. This eating pattern may affect exosome release and function. It can be effective for some people, but it may not be suitable for everyone. Always remember to consult a healthcare provider before starting any new dietary plan. Stress reduction is often overlooked, but is equally important. Chronic stress can alter exosome profiles, leading to a cascade of health issues. The good news is that stress reduction improves overall well-being. The downside is that it can be challenging to implement, particularly in high-stress environments. So, it's time to explore those yoga classes or mindfulness apps you've been hearing about. Let's not forget about sleep optimization. Poor sleep can affect exosome release, leading to a host of health problems. It's essential for overall health, but it may be difficult for those with sleep disorders. So ensure you're getting that recommended 7 to 9 hours of sleep each night. Now let's talk about something a bit more futuristic. Exosome-based therapies. These are emerging treatments using engineered exosomes. They offer a targeted approach, but they are still experimental and may have unknown long-term effects. So, keep an eye on this space for further developments. Lastly, we have the anti-inflammatory diet. Reducing inflammation may positively influence exosome function and insulin resistance. It's a natural approach, but it may require significant dietary changes. So, if you're a fan of processed foods, it might be time to start embracing those leafy greens and omega-3 rich foods. These are some strategies that can help manage insulin resistance, but remember, always consult with a healthcare professional before starting any new regimen. We've covered a lot today in our exploration of the role of exosomes in insulin resistance. These tiny yet significant cellular messengers have a profound impact on our body's response to insulin and subsequently our overall health. We delved into 10 ways exosomes are involved in insulin resistance, highlighting their role in adipose tissue communication, muscle-liver crosstalk, pancreatic beta cell function, inflammation mediation, microRNA transfer, lipid metabolism, endothelial dysfunction, macrophage polarization, skeletal muscle insulin sensitivity, and hypothalamic regulation. We also examined potential strategies to manage and prevent insulin resistance, considering how regular exercise, dietary interventions, intermittent fasting, stress reduction, sleep optimization, and even emerging exosome-based therapies could play a part. Despite the complexity of this topic, we hope we've managed to shed some light on it. Understanding the role of exosomes in insulin resistance is not just a matter of academic interest. It's about empowering ourselves with knowledge that can lead to healthier choices and better outcomes. Whether you're a medical student, a health professional, or simply a curious individual, applying the strategies discussed here could make a real difference. Regular exercise, mindful eating, stress management, and quality sleep are not just good for your insulin sensitivity, they're good for your overall well-being. And let's not forget the exciting potential of exosome-based therapies. While still in the experimental stage, these could offer a targeted approach to managing insulin resistance in the future. Thank you for joining us today. Your active participation is what keeps us going. Whether you've been with us since part 1 or you've just discovered our series, we appreciate your engagement. Don't forget to like, subscribe, and share your thoughts in the comments. We thrive on your feedback and it helps us shape our future content. As we wrap up, I want to emphasize the exciting potential of exosome research in understanding and potentially treating insulin resistance. By recognizing the role of these tiny cellular messengers, we open up new avenues for managing metabolic health. Before we conclude, I must provide a brief disclaimer. The information in this video is for educational and entertainment purposes only. Any health-related decisions should be discussed with a licensed physician. Your individual situation may require specific medical attention, and it's crucial to seek professional advice for personalized care. Thank you for joining me in the Victory Education Lounge. If you found this information helpful, please remember to like, subscribe, and share your thoughts in the comments. Your experiences and questions can help others on their health journey. Stay tuned for our next video where we'll continue to unravel the mysteries of health and wellness. Until then, keep questioning, keep learning, and keep striving for better health.